students. So the topic for today is arrays in C. In this lecture, first we will see how a programmer can make use of single dimensional arrays in a program. And after that, we will see how one can do different kinds of processing on a single dimensional array. And finally, we shall discuss how one can pass an array as an argument to a function. Sequence of elements. Many programming problems require you to maintain a sequence of elements of the same data type. For example, consider a program to sort a sequence of elements. Say you are given with a set of n numbers and you are asked to sort the given list of numbers in some order. So for this problem, the programmer has to store the sequence in the computer memory at the same time. Unlike a program to find, say, the largest of n numbers, where you need not have to store the sequence, you can do an online processing while you read the numbers from the user. But to sort, you have to store the sequence in the memory and you have to do the required processing on it to get the list sorted. Another example is a program to maintain the marks obtained by the students in an examination. Maybe the program needs to provide functionalities like finding the largest mark, least mark, or average mark, or to prepare a ranked list of students based on the marks obtained in this examination. So for this program also, the programmer is required to store the sequence of marks obtained by the students. So what C provides to maintain a sequence of elements of the same data type is what is called an array, which is a data object. So consider a single dimensional array. We will define it formally later. The figure shows the pictorial representation of an array in C, namely dsec, which can store up to 5 decimal values. So the figure represents that now the array contains 5 elements, 10, 20, 30, 40 and 50. So how will you access or refer the elements in an array? And it is possible through what are called indices, and the elements are accessed by indexing the array. So these are the indices. If there are n elements in the array, then the index value ranges from 0 to 4 in this case, and in general 0 to n minus 1, where n is the number of elements in the array. Okay, so sequence, that is an ordered set of elements, and the first element is stored at index 0, the second element at 1, and likewise the elements are stored till the last index, which is n minus 1. In this particular example, n is 5, and so n minus 1 is 4. Ith element for all values of I from 0 to n minus 1 of the array, say dsec, can be referred by dsec I. So let me call it as dsec I may not be pronouncing these brackets, square brackets, which is required to refer to the ith element. So dsec I. For example, dsec 2 is referring to the element with the index 2 and its value is 30. Now we can see how an array is stored in memory. See this example function foo, and here our purpose is to see how memory for this array d6 is allocated when an instance of foo is created. So this blue arrow represents that this function foo is invoked during execution, and the creation of instance of foo requires to allocate a sequence of 5 consecutive memory locations to dsec. So this should be read as 5. Sorry for the typing mistake. So what is important here is consecutive memory locations. So 5 consecutive memory locations. The figure shows the memory layout, and according to this figure, the 5 elements can be stored in these memory locations. Here the assumption is that each integer requires 2 bytes of memory to store its value. So the locations 500 and 501 is used to store the first element, and likewise the other elements are also getting memory allocated. So the memory allocation should be consecutive. That means it needs to find a sequence of 10 consecutive free locations in memory. Then only the instance can be created. And the elements of the array dsec can be referred by dsec I for all values of I from 0 to 4. So these are the indices shown here. So the first element is stored at index 0, second at index 1, and so on, until you reach the last element where the index is the maximum number of elements in the array minus 1. For simplicity, we shall represent this kind of a memory allocation simply as this. So here, this picture shows that dsec is an array which can store up to 5 elements. Okay, so now onwards, for simplicity, we may not be drawing the memory layout. So this kind of a memory layout will be represented by this kind of a figure. And to access the elements of a memory, the programmer need not worry about the memory address. She can just access it by using this syntax, where I is an index varying from 0 to the maximum number -1. The array name here dissect represents the starting address of the array. For example, the starting address of array allocated for this instance is 500. So the array name just represents the value 500. If you try to print the value, then you can see that the value 500 is printed by using an appropriate conversion character in the printf statement. You can print the value. And how exactly an element is accessed is actually by using a base address, which is 500, and an offset which is given by the index. And the details of how exactly the memory address is calculated for accessing an element is beyond the scope of this subject. One-dimensional array declaration. So here is the syntax for declaring a one-dimensional array. So what are the different components in it? See. So first is the data type, which is the type of the elements in the array. So array is a homogeneous data object, which means all the elements in the array must be of the same data type, and this represents the data type of all the elements in the array. And the next is the name of the array. As I said, the name of the array with the index can be used to access an element, and array name is basically nothing but the first memory address of the array, which is created when an instance of a function with the array declaration is created. And the third element is the size of the array, which is nothing but the number of elements in the array. For example, suppose we create an array with size as 100, then up to 100 elements can be stored in the array. When I say up to, suppose the programmer or the user, when she executes the program, gives only 50 elements, then only the first 50 elements will be used. Okay. And what can be the size? It can be a positive integer. It can be a positive integer constant or a constant expression resulting in a positive integer. That means for size you can just say 100. It's a constant. Or you can even say 20 into 4. 20 into 4, which gives you 80. But it's not advisable to use such a constant expression, but literally it allows it. And what it is not allowing is you cannot use the variable here. And why is it? And that we will see later. And for this, you can use a symbolic constant. For example, you can define a symbolic constant like hash define size 100, and then you can use size here. And before the execution of the program, this symbolic constant will be replaced with its value. It's very useful to use symbolic constants to declare an array. For example, suppose that You declare an array of size say 50. Maybe that you need to have various arrays in your program with the same size, say 50. And later suppose a programmer realizes that the number of elements required to be processed is up to 70. In that case, you need to go and change all the declaration statements if you are using 50 in each of the array declarations. But if you are using a hash defined statement like size 50, then what you can do is you can just change the definition of the symbolic constant. So that is a very useful feature, and we will see examples later, and we will discuss more about hash defined statements when we discuss macros later in this course. So how can you access a one-dimensional array? Here is the syntax. So what are the different components in this? First is the array name, which is followed by the index of the required element in the array within square bracket. Note that the value of index should be in this interval from 0 to size -1, including these two. And any value other than this will cause an error which is called array out of bounds error. And if you use such a value, the program may crash. So it's very important to make sure that when you work with an array, whatever index value you specify is within this range. C does not provide operators to act on an entire array. For example, suppose you want to print, or maybe you want to increment all the values in the array. C is not allowing you to do so by using a single operator on the array. Rather, any such operation should be processed on an element by element basis, one at a time. So basically you will access an array by using this kind of a syntax, and this can be used. For example, suppose this array name is the data type of array is integer, then an element can be used anywhere just like an integer. Okay. So now we're going to see how can you process a one-dimensional array. Sequencing through a one-dimensional array. So I said C is not providing us any operator to act on an entire array. We are supposed to process the elements of an array one by one, definitely by indexing the array, and the indices is shown here. It varies from 0 to n-1, where n is the number of elements of the array. So the value of index, if you want to access the array element by using this, so this is not the assignment I mean, the value at dsec I is 10. So what is the I now? I is now 0. So first the index must be 0. To systematically process the elements of an array, the index must be initialized to 0, and you can access the first element. Now dsec I is 10, and then I must be incremented now it's 0, it goes to 1 and the value is 20. Okay, so next I needs to be incremented again and it goes to 2 and the value is 30. Then to 3, the value is 40, and finally to 4, the value is 50. And that is how we can systematically process the elements of an array in the given order, starting from the index 0, going to the last index, which is n minus 1. Sequencing through a one-dimensional array can be implemented easily with a for loop as shown below. Suppose you want to do some kind of processing on an array. In this particular example, there are 5 elements, so how will you access is like this. This is exactly what we saw now. Initially, the index was 0, and then you do the required processing on the array. You access the array element and do whatever you want with that, and then you increment the value of index and repeat. So initially you access the 0th element, then the increment and first element, and likewise it progresses. So in this example case, it's 5. Less than 5 means the value of I goes till 4 and it accesses all the elements, and when it becomes 5, it gets out of the loop. So in general, this value should be n, where n is the number of elements in the array. So that is how one can systematically process the elements of a single dimensional array. So here is an example which shows how you can read elements to a single dimensional array. Assume that you have created a single dimensional array dsec with maximum 5 elements. And suppose you execute this part of the program, and what is it doing? It tries to read 5 numbers from the user. So when this printf statement is executed, this will be displayed on the screen, and because of these scanf statements, you know that the control will wait for the user to enter 5 numbers, and assume that the user gives these numbers 10, 20, 30, 40 and 50. Then when you finish executing this part of the program, what will be the new state of the array? It will be this. Because of this loop, first you read the first value, that is 10, to dsec 0, so 10 is stored here, likewise it reads and stores these values in this order. Okay, so now see how can you display the elements of an array. For that, assume that you have an array dsec with 5 elements and all these elements are stored. So what will happen when you execute this part of the program? If dsec is having these elements stored, so what is it trying to do? It's trying to display the element. First, it displays this message. Then in the next line, it prints the values at index 0, 1, 2, 3 and 4, and 2 values are separated by 2 blank spaces. So if you execute, you can see that this will be printed on the screen and the array is not modified, because of course we are just accessing it, we are not modifying. Okay, good. So this is another example. Say I want to do some processing on this array. Assume again that dsec is a array of 5 integers with these values, and suppose you execute this part of the code. What is it trying to do? So first, for I equal to 0, what it is doing is dsec 0 is equal to dsec 0 plus 0. So at 0, 10 will be stored, and at 1, what will be stored? So it increments I to 1 and it comes back. Dsec 1 is equal to dsec 1, which is 20 plus 1, so 21. So see what happens. So the elements stored as 10, 21, 32. Why is it 32? Because already here 30, 30 plus. Now the value of I is 2, so 32. Similarly 43 and 44. I think these 3 examples are enough to give a clear idea about how can you do various kinds of processing on a single dimensional array. Okay. If you know how can you process an array, then let us consider how can you delete an element from an array. So how can we delete the element at index k? For example, suppose k is equal to 2. So what is stored at 2? Now 30. So you want to delete 30. So how many elements are there before deletion? 5 elements. Then, and the elements are 10, 20, 30, 40, 50 in that order. So deletion of 30 should give you an array with the 4 elements, 10, 20, 40 and 50 in that order, right? So how will you do? Deletion can be implemented by shifting all elements from position k plus 1. Here k is 2, so from position k plus 1 to the last element, what do you do? Shift the elements. Shift 40 to this position and then shift 50 to this position, and then you are done. And because you deleted or you want to delete, you decrement the number of elements by 1. See how which can be performed. So first you want to transfer the element from 3 to 2. Okay, you are saying d sequence of I when I is equal to 2. Dsec 2 is equal to dsec 3. So this assignment. Okay. So see that in the previous instance 30 was here. Now you assigned 40 to index 2. So it is overwritten and the value 40 is there. Nothing is happened to the value at index 3. So what is next? Next you want to do this shifting. Yeah. So again the statement is saying dsec I equal to dsec I plus 1 for I is equal to 3. So see that in the previous case 40 was here, so 50 is copied to this point. And in this example we are done, except for decrementing the number of elements. So if you carefully look at what we did, you can see that for deletion one needs to perform the above statement for all values of I from k to n minus 2. So what is n? In the given case n is not 5, n is not 4, n is 5. Okay, so you have to do it till I reaches 3. You are here and you are copying this element to this point, that is n minus 2. Okay, I think it's clear to all of you. Good. So how will you write this in your program? It may look like this. So the part of the program to delete. So we know that we need to do dsec I is equal to dsec I plus 1 for all values of I from k to n minus 2. Okay, so we can do it like this. For I is equal to k, I less than n minus 1. That is till I becomes n minus 2. When I becomes n minus 1, this condition is failed and it comes out. So till it becomes n minus 2, you do dsec I is equal to dsec I plus 1. So this loop is enough to do all the shifting, and then finally you need to decrement the number of values by 1. Not that the last value is there, we are not erasing it, but effectively now the number of elements is decremented by 1. Previously it was 5, now it is 4. The moment you made the number of elements as 4, the values can be accessed from 0 to 3, and the values are 10, 20, 40 and 50. So you implemented the effect of deleting 30. Not that when I say decrement the size, I am not altering the memory allocation. I say the maximum index value is now decremented by 1. That's it. Once the memory is allocated by using a declaration statement like what we discussed, there is no way to remove a part of the memory which is allocated to the array. So, but you can modify the number of elements to reflect that the number of elements is decremented by 1. Okay. Another operation, how will you insert an element into an array? So how can we insert a value, say 30, at index k, for example k is equal to 2. For inserting an element, suppose the array is declared to have maximum 5 elements, then to enable the insertion operation, the maximum number of elements stored in the array must be 4 or less, because if it is already 5, you cannot insert. So that is a basic assumption. When you want to insert, assume that the number of elements stored in the array is strictly less than the maximum number of elements possible in the array. When I say maximum number of elements, I mean the size of the array that you have specified when you declared the array. If the size is 5 and if you have only 4 elements, then you can insert one more element. Okay, that's it. So how will you do that? I want to insert 30 at this point. So if you do that, after that, what should be the array? The array should contain 5 elements, 10, 20, 30, 40 and 50 in that order. So what you want to do is, you want to shift 50 to this point, and after that 40 to this point, and then you can write 30 into this position. This is what you can do. So can be implemented by shifting all the elements from position k. K is where I want to insert. One position to the right, and if you do that, you have to you cannot copy 40 to 50, then you will be overwriting this value. So you have to do it from this point. You copy from here to here, then you copy from here to here. That is the order. After you do that, that means once you shift all the elements from here, one position to the right, then you are free to store your new value into the required index. Okay. Then finally you have to increment the number of elements to reflect the insertion. Okay. So first what you do this shifting. And how will you do that? You say dsec, this is one way of doing it. You can say dsec I is equal to dsec I minus 1. So I should be here. So you place I to n. Now see, before insertion how many elements are there? n, 3 elements. So n is 3, right? Sorry, I'm very sorry. Before the insertion, the largest index is 3 and the number of elements is 4. Okay, so you're saying n is 4, the number of elements stored is 4. So you're saying dsec at 4 is equal to dsec at 3. Okay, so after that what you do? So that means before this operation this was the case. After this operation, now this 50 is copied to this point. Now you are free to overwrite this. So you want to shift 40 to this point, and for that what you do is you do this same statement for the value of I equal to 3. So you are saying when I is equal to 3, dsec I, that is dsec 3, is equal to dsec 2, I minus 1 is 2. And in this particular example, you have done the shifting. And if you formalize, what you are doing is, one needs to perform the above operation, this operation, for all values of phi from n to k plus 1. See, in this case, before insertion, n was 4 and k was 2. And you did it till I reaches 3 starting from 4. So n to k plus 1, where n is the number of elements in the array before insertion. I think it's clear. Is it? Good. Now see, how can you write it as a program? So this is that shifting. I said you have to move, or you have to do this operation dsec I is equal to dsec I minus 1, this operation for all values of phi from n to k plus 1. So I equal to n till I greater than k. Okay, that is until the value of phi becomes k. So till k plus 1 it will do it. So the shifting is done. Okay, so this loop do the required shifting, right shifting, and after that you need to execute this statement. What are you doing here? Now you have shifted all the elements one position to the right, and now this position is free for you, and you can write the new value, which is 30. Assume that this value is 30 to this position, that is 2, k is 2. So that is what you are doing. If you execute, you can see that for this 30 will be assigned here. Yeah. So the insertion is done. Now how many elements are there? As you see, 10, 20, 30, 40 and 50 in that order. And so the number of elements is 5. Previously it was 4, so n was 4, n must be increment. Okay. So now we know how to read elements to an array, how to display the content of an array, how to access the elements, how to delete an element from an array, how to insert an element. For insertion, there has to be at least one free location. That is, the number of elements currently stored must be strictly less than the maximum number of elements possible in the array. And recall that in C you are not allowed to process the entire array using any operator. The array must be processed on an element by element basis. So you have to sequence through the array, and when I say sequence, you start from array index 0, you do the required processing with that element. Maybe you can read it or write a new element, and then you proceed to the next index and process it. Likewise, you go till you reach the last index. Maybe the array is of size 100, that is, the array is created with a maximum capacity of 100 elements, but the current instance of the program stored only, say, 13 elements. Then the index value range from 0 to 12 if only 13 elements are stored. Okay, so we know how to insert, how to delete, how to process the array systematically from index 0 to index n minus 1, where n is the number of elements stored in the array, and that n must be strictly less than or equal to, it must be less than or equal to the maximum number of elements possible in the array. Okay. Now we are moving to the last part of this lecture. Here we will see how one can pass a one-dimensional array as an argument to a function. See this example. Here there are two functions, namely foo and bar, where foo is making a call to bar and it's making another call to print array, which is not shown, which I assume that a function, user-defined function, which takes this array and prints its content. Okay. And the purpose of this example is to see how an array is passed to a function, and the array as an argument is dealt in a different way than the arguments that we discussed in the last class. Now let us see how is it happening. So this blue arrow shows that during the execution of the program with these two functions, foo is invoked for execution. So when foo is invoked, instance of foo is created and only data object, you can see it's array, gets memory allocated. So what is this array? It's declared to store a maximum of 5 individual elements. So we know that then the system should find consecutive memory locations to store 5 integers, and our assumption is that each integer requires 2 bytes of storage. So 2 into 5, 10 bytes of memory, consecutive memory is required, and assume that this is the memory layout. Okay. So why I am showing the memory layout? Because it's very important to explain how array is passed as an argument. Okay, so array is just declared. We don't know what values are there. So some values are there. We are not interested in knowing what values are there. But array is created. The index values range from 0 to 4. We are 0 to 4, and the array is created. Okay. And how this function foo will be executed? First executable statement is this function call. We all know what is going to happen when you call a function. We know that the instance of the function bar which is called needs to be created. Yeah, the function call happened, an instance is created. You see only one more item is created. Instance of 1 is created and the data object I gets memory allocated. See that here there is an argument, formal argument, which is this B array, and another variable which is I, and only I is getting memory allocated. and array is not B array is not getting memory allocated. See, when an array, here say a array, is passed, its memory address is passed to the called function here bar. So what is it? Its address. What is the address of a array? Is 500. So what is it saying is this 500 is passed, and this B array is also having the value 500. That means A array and B array are now representing the same object in the memory, which is this array. Okay, that's what I'm saying here. Both A array and B array represents the same data object in memory. And these are now called alias. A array and B array. Alias means because both are pointing to the same memory object. Okay. So whatever you do here in this program, in this part of memory, will be reflected in this part also, because you are actually modifying the elements in this part of the memory. So what is to be noted here is, when you pass an array as an argument to a function, this the instance of this function is not getting a new array allocated to it, but rather it just gets the address of this array, and both B array and A array are pointing to the same array allocated in the memory. So both the actual argument and the formal argument are representing the same memory object. Okay, but I is a variable of this function. So for this instance, I is allocated. I assume that these are the 2 bytes allocated to I. Okay. Now what this program is doing, if you carefully look at this program, what is it doing is, it accesses the values in that order 0, 1, 2, 3, 4, and what it is doing, it adds a value of I to 10 and assigns it to array. Okay, so 10 plus I. So initially I is 0. So what is 10 plus I? 10 is getting stored at 0. Okay, see, when you execute this program, when you come to this point, what you have done is, you initially said B array at 0 is equal to 10 plus 0, which is 10, and then in the next round B array at 1 is equal to 10 plus 1, which is 11, then B array 2 is equal to 10 plus 2, 12, the next 13, next is B array 4 is equal to 10 plus 4, and that's it. So now the control is coming to the return statement. See that there is actually a typing mistake here. I should say the return type is void. Okay, sorry for that mistake, and read it like void bar. So no value can be explicitly returned. So in such a case, you can just say return semicolon. You are not explicitly returning any value, but you are going to return the program control back to this point. And because these two functions shares this array or this part of memory, whatever changes made by this function in this memory is reflected here as well. See, when it returned the instance of I is deleted. Previously you can see I was here, that is deleted, but this instance is retained, and now this program is able to access it through AR. Okay, so it comes to the last statement, and I assume that the print array is a function which takes this array and displays its content on the screen. displays like the elements of the array, and then it prints all the elements. So what will be printed? See, this will be, this may be what this function is doing. It takes the array and prints the elements 10, 11, 12, 13 and 14. Okay, this is how array is passed as an argument to a function. Rather than making a copy to the called function, the calling function and the called function share the same array. So whatever changes that the call function is doing will be reflected here. Thus, array is giving us a mechanism to return a number of elements from a call function. This is like returning all this array, all the elements of this array. Okay, so the take home from this part of the lecture is that unlike ordinary variables, when arrays are passed as arguments to a function, then the address of the array is passed and the formal argument gets that address, and hence the formal argument and the actual argument refers, both are same, and is nothing but starting address of the array, and so the call function can also access and modify the array which is passed from the calling function. Okay, I think is clear, and if you have any doubt, please feel free to ask me questions through the Google Classroom for our course. Okay. Now, see the syntax for passing a one-dimensional array as an argument to a function. Here is the syntax. So, what are the various components? So, first is the function name, the name of the function to be called. In the previous case, it was bar. And then the array name. See that it's just the name of the array. No need to use the square brackets. It just represents the starting address of the array. Also, not that when an array is passed as an argument to a function, the same array instance in the memory is shared between the calling function and the called function. In the previous example, foo and bar. When foo calls are by passing a array as an argument, the address of a array in the previous example, 500, is passed and is getting started at B array, that is B array is again 500. Now there are two variables pointing to the same memory location, that is 500, which is A array and B array. So you can access the array using A array or B array. But being called, the function bar is in execution. So now the function bar is going to access the memory using B array. And once it finishes, the control goes back to the call function. At that time, the call function can continue accessing the same array using its array name, that is A array. Okay. Now, how will you receive an array as a formal argument? So this is the syntax. So different components are the data type. Okay, it has nothing to do with the array. It's the data type of the value which is to be returned by the function. In the previous example, it must be void. And next is the name of the function, which is called. This is the first line of the definition of that function. So in the previous example it was bar, and followed by the formal argument specification, that you know that the data type followed by the name of the variable, and the data type is the data type of the elements in the array. You know that all the elements must be of the same data type. In the previous case it was int, so this is the data type of the elements of the array, and followed by the array name. In the previous case it was BRA. Okay, name of the array to be received. So not that you don't have to specify the array size here. Okay, just specify name. Okay, you are not this function when its instance is created is not going to get a copy of that array in the memory, but rather it is going to refer to the same array passed by the call function. Okay, and this is the last slide of this lecture, and in this slide I am giving you a number of exercise problems from today's lecture. So what is the first problem? You are supposed to write a menu driven program with the following functionality. When I say functionality, you need to provide me a menu driven program with a function for user defined function for each of these. So you give a function to read a sequence of numbers. Actually the record statements are already discussed. Then next a function to display the content of the array, that also we discussed. And the third exercise is to provide a functionality or implement a function to search for a given element in the array. That is, when the user is exercising this option, the user is expected to give the value of an element, and the function is to search whether the given value is present in the array or not. Okay, you can write a function which returns a valid index in the array, that is from 0 to n minus 1, when the element is present. You return the first index at which the element is present. Okay, if the element is not present, you return minus 1. Okay, you can make the function returning on integer, and returning any value between 0 and n minus 1 means the element is present, and the index is where the element is present. And students, note that we discussed the algorithm, flowchart, and pseudocode for this problem. So refer to that and try to convert it into a function. Okay. And the fourth problem is to delete a given element from the array. Just give a function, you know how to do it. And the last one is to eliminate duplicates in the array. That is, you pass array as an argument to the function, and you eliminate the duplicates. Whatever logic you want, you can apply. So you have to take an array of elements, and after that processing, there should not be any element repeated in the array. If there is an element repeated, you delete it. Okay, only one instance you need to keep. It's up to you what kind of a logic you are going to apply. And the last exercise problem is to sort the elements of the array in non-decreasing order. Okay. Non-decreasing order means it must be in increasing order. When I say non-decreasing, there can be repeated element. That is what I say non-decreasing. Rather than saying increasing, I say non-decreasing, because there may be some numbers repeated. So here again, students, not that we have discussed in the class the algorithm, flowchart, and pseudocode for doing bubble sort. So please refer to that and try to convert it into a function. And that's all for today, and looking forward to see the solution for the exercise problem. Thank you.